Jai Hind all, this is Assistant Professor Gagandeep Singh from Ajay Kumar Garg Engineering College. We are discussing the unit for design of general impedance circuits, GICs. In the last lecture, we have discussed that there is a GIC called gyrator, which is a two-port network, and its input is proportional to the output impedance. So input impedance is proportional to the output impedance with proportionality constant of R square. R square is the gyration resistance. We have seen that when it is open, when there is no load, then the circuit Zin has infinite, or it acts as a open circuit. So when we are closing input, and it is acting as a open. And we have also discussed that this circuit can be taken as a replacement or a circuit whose characteristic is same as inductor. So we can take GIC as replacement of inductance, whose behavior is similar to the inductance. We have seen two GIC circuits. One is called GIC1 and other is the GIC2 circuit. So this is GIC1 circuit and GIC2 circuit. So we have two circuits whose behavior is such that it is proportional to the inverse of the load impedance. So till now we have discussed a inductor which is our grounded inductor. So we have designed the impedance GIC, impedance converter circuit, which is a grounded inductor. Now in the most of the cases, for example, when we discussed some filter circuits, we are discussing some of the ladder circuits that we will discuss just after some time. So when we are discussing some inductors, those are generally connected with the two ports, means there is no part of the terminal of the inductor is grounded. So we can see that if it is connected in a circuit, the terminal, both terminals, the two terminals of the inductor will have some voltage. None of them will be zero, or none of them will be grounded. Most of them are connected in a circuit. So if we say this inductor which has a 1 and 2 voltage, the two voltages at 1 and 2 will be at different voltages, and none of them will be equal to 0. Now if we see this inductor, we can see it divided into two parts. Let's suppose this inductor is two parts. One is when we see it from the one side, from the one port, and other is when we see it from the second port. When we see it from the one port, it can be taken as a one port whose input impedance is Z11, and the second one is the impedance. Second is the inductor whose impedance is Z22, and so we can divide it into two inductors, and one inductor can be replaced by one GIC. So we can have one inductor whose two input impedances can be seen differently for 11 and the 22. Now for this Z11 is one inductor whose impedance can be taken as Z11 is equal to SL. Similarly, for the second inductor, we can say it is Z22 as SL for the output terminal. Now, if we connect a gyrator on the either side of the grounded capacitor, it relies a floating inductor. That means one is a gyrator and another is the gyrator, and we connect the capacitor in between, then it will act as a floating inductor. So we can draw this one using gyrator as one gyrator and the second gyrator with connected a capacitor. Now if we see this whole gyrator circuit, one circuit has open circuit, and for till 4 terminal, one circuit is open and the output is connected to a capacitor. So this is one inductor which is on the 11 to the 22. And for the other circuit from 3 to 2 terminals, this can be taken as the second terminal, which is 1 dash to 2 dash for Z22 dash impedance. So this whole circuit can be taken as another gyrator with capacitor as the Z22 load. So this whole circuit, this whole terminal, this whole arrangement of gyrator will give a floating inductor. That means an inductor whose none of the terminal is at the zero potential, or both terminals are at the different voltage levels. Now, if we say this is using GIC, how we can draw? We know that the floating inductor simulation can be done by using two GICs as the gyrators, as in the case of gyrator. The output port of two gyrators are connected to a floating resistance R. This R is same as the R5 in GIC. So we can connect two GICs which are mirror image of each other. Mirror image because in the input terminal we have 1 dash and other terminal can be seen as in the previous case, other terminal as grounded. And the second one is the mirror image of that. That means 2 if we give the input and other is the grounded. So here we have one GIC and other is the mirror image of that. So this one is the one GIC and mirror image of that can be connected such that R5 is common to them. So both will give two GICs. Both GICs will give one floating inductor simulation, a behavior which is similar to the floating inductor. Now, what is the use of these gyrators, these circuits, or these floating inductors? Now, most of the cases we use ladder circuits for the passive design of the filters. Now, this circuit which is repetitively consists of L and C or R components which are repeatedly used, that circuit is known as the ladder circuit. A circuit whose which is lossless is called lossless ladder. Some of the properties of these lossless ladders is that a lossless ladder generally consists of L and C. R component is generally lossy component. So this do not contain any R component. And L and C, because they do not consume any energy, they do not have any loss. So this ladder circuit which is consisting only L and C, those are known as lossless ladders. Generally, these lossless ladders means R and L and C circuits with L and C components are used because they have low sensitivity performance to the component tolerance. Generally, this is also used for the doubly terminated ladders. Doubly terminated ladder is a ladder whose input is a resistance and output is also a resistance. Input series resistance and output is a resistance. We will see just after this slide. So this passive or the lossless ladder is used over active circuits because of their excited low sensitivity performance to the component tolerance. This makes this passive circuits the realization of the active version of the lossless inductors with using passive filters which has a low sensitivity of features. So we can use components of L using GICs which gives the combination of both passive as well as active circuits. Another reasons why we use lossless filters using ladder circuits. One is that it is the main advantage is that it do not consume any power. So if we do not have any power available to drive the active filters, active devices, it can be used. Another thing is that we can make it enable it in the IC designs. So we have an availability of enriched material for these designs of LC circuits. So that's why we are using LC circuits in the lossless ladders. So ladders, low sensitivity property of LC ladder is valid for doubly terminated ladder. As we have discussed, the doubly terminated ladder has some advantages. Their sensitivity can be worsened when either one of the terminal are absent. But either one of the terminal absent means either we have R1, this R1 as 0 or R2 as open circuit. As we have discussed, doubly terminated means either we have R1 or R2 are present in the circle. So R1 is present and R2 is present. If R1 is in the series and R2 is in the parallel to the ladder circuit, that circuit, this ladder circuit is lossless, means it is a combination of lossless L and C components, purely L and C components. And R1 is series input resistance and the output resistance is parallel to the 2' terminal or the load resistance. This terminal is known as the ladder circuit. One circuit can be seen as this example, where we have L and C are in repetitive combination of L with C combination. So L1, C2, L3, C4, L5, C6 are lossless ladder, and it is doubly terminated because of R1 and R2. Now this circuit, if we see, this circuit is a 6th order Butterworth filter. So 6th order all pole lossless filter, Butterworth filter, is giving the lossless ladder circuit. So now if you can see here, the most of the L1, all the ladder circuit in the all the inductors in the ladder circuit L1, L3 and L5 are not floating. They are doubly terminated, or sorry, they are floating inductors. So we have to use two gyrator circuits here. Now the problem with GICs is that we have to use a number of op-amps. For one inductor we have to use 4 op-amps as well as the R5 impedances. So we have to use a number of impedances as well as a number of op-amps. So this will make the whole circuit more complex and more bulkier and more costlier. So there are other circuits, other techniques that are proposed for the ladder circuit design or replacement of the inductor. The first replacement that we have seen, that the active simulation of passive ladder LC circuit can be used by replacing it grounded and the floating inductor by its active components, for example gyrator or GICs. And we have discussed that if we replace it with GIC, a large number of op-amps, for one floating inductor we need 4 op-amps. So if we have a 6th order, we have 3 inductors, that means we have to use 12 op-amps for one inductor, for one circuit, which make it a calculus. There are other techniques which is known as a Gauss-Popeil technique and Bruton's technique. These two techniques are also giving give replacement of the inductor. That means we can realize this passive component using these two techniques by the active components. These two techniques, first technique gives the simulates the behavior of the inductor. So if we use L circuit, its behavior will be similar to the circuit proposed by Koski-Popiel procedure. Second is the Prudhon's FD-NR technique. This gives the completely replacement or gives the completely elimination of the inductor by resistors. So when inductors are replaced, then it can be easily, the whole circuit can be free of all shortcomings of the inductor. So these two techniques are to be discussed in the subsequent slides. Thank you. So in today's lecture, we have discussed the basics of the GIC. Then we have discussed from grounded inductor how we can create a floating inductor, and then we have discussed the application of these inductors where these are used in the active filter design, from the passive filter to the active filters. Generally, these are used in the ladder circuits. So we have discussed some properties of the ladder circuits, lossless ladder circuits, and ultimately we have discussed that how these ladder circuits can be implemented using our designed GICs and the gyrators circuits. So in the next lecture, we will discuss the different techniques through which we can eliminate the inductors. Thank you.